All right, here we're on section 8.5, and we're going to work some exercises on the absolute value equations and inequalities. All right, so the first one says we're supposed to determine whether x equals 1 and minus 1 are solutions to the given absolute value inequality here. So what we're going to do is we're going to plug both in and see if it works. So 9 minus 4 times 1, absolute value of all that, less than or equal to 3. Well, here we get 9 minus 4, and that gives us 5. And that's all supposed to be less than or equal to 3. Well, this is going to be 5 less than or equal to 3. No. So it's not a solution. What about the other one? Well, there we're just going to change the plus 1 for a minus 1. And so 9 minus 4 times a minus 1, absolute value, and then less than or equal to 3. And so then that's going to be 9, and then that's going to be a minus 4, and then plus 1. So it's going to be a plus 4. Wait, and yeah, minus 1. Okay, plus 4, less than or equal to 3. And that's going to be 13 less than or equal to 3. And that's going to be false again. Okay, so 1 is not going to work, and a minus 1 also is not going to work here. So neither one of those work here. Let's try the next one. Here we're supposed to graph the absolute value equation. All right, so a couple things here. We could do different ways. We could get it to the form where we have absolute value of some kind of a times and x minus h and do it that way, or we could just simply plot points and get it that way. So I think the easiest way maybe is actually to plot points. And so let's do x and y. And so if we think about this, whatever we do is we have to be within 20. So if we plug in 0 here, we're at 24. So anything basically to the right of 0 is going to be too big. If we plug in anything to the left of 0, it's going to fit within our graphing constraints here between, 20 and negative 20, left and right, up and down. So let's start with a minus 1. So a minus 1 is going to give us what? Well, that's going to give us 18. And if we do a minus 2, that's going to give us a minus 12, plus that's going to be 12. And if we keep going down, minus 3, that's going to be minus 18. So that's going to be what? A 6. And then if we do a minus 4, that's going to be a 0, minus 5. Well, guess what? We better be starting to go back up again. And so minus 5, that's going to be a minus 30 plus that. So that's going to be a absolute value of a minus 6, which is going to be a 6. And then a minus 6 should give us 36 minus that. So that'll be 12 after we take the absolute value. And so basically, we're going to go here, minus 4, 0. That's going to be our point. And then we'll have minus 3, and then we'll have a 6, and we'll have a minus 5, and we'll have a 6. And then we'll have each one of those is going to give us a 12. So we'll go up here to 12 here. And I think 12 is about there. And so what we're going to get is really a very narrow. Whoa, that's horrible drawing. Not even close to the lines. Let's erase that and try it again. So that's going to do something like that. And then again, it's going to go way off scale there. And then we come up over here. And it's going to keep going up and go way off scale. Okay, so that's kind of what we have. Now this one, what we'd have to do is we'd have to factor out the 6, and then that's going to give us a 4 here, which would give us our minus 4, because remember, it's going to be a minus 4, so we'd go over here, and then after that, we would just have the absolute value, and it's going to be shrunk in, and we'd just move it up, and that's going to how it would work there. So kind of gives us the same thing, but without the extra stuff. All right, let's pause there and come back for some more.